Okay, so this is shear. The intersecting plane is X and it's got with Z, and this is shear ZX. Okay, so there you go. So now we know all our stresses. We got a few zeros, which is good. We are going to construct 3D mold circle. Okay. So in 3D mold circle, or in mold circle, not 3D mold circle, not just 3D mold circle, we have an x-axis, and the x-axis is basically normal stress, right? So we have normal stress of up to negative 15. So if I'm going to go on, I'm going to do some quick calculation. So I'm going to draw my mold circle. So this is minus 22, 20, 18, 16, 14, 12. So these are the stresses. I better make sure it's right. Here, 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 here. Yep. Minus 6, minus 4, minus 2, 0, 2. Maybe I need a bit longer. Maybe I need a 4. Okay. And this is my normal stress. Okay, so that's our normal stress. Let me see if my scale is good enough. Okay. Maybe it's not. Hold on. My normal stress need to be higher. I have to change the scale. I do apologize. My bad. I think it's too. I need a 14. Maybe I draw it a bit smaller. So this is minus 20. Okay, I'll do this minus 15. Okay, not the best scale, but then I'll be fine. If not, the circle might be too big. Okay, so in most circle, this is our normal stress axis, right? Then we have our shearing stress. So the shear, we tend to write the shear stress, and then we tend to write rotation of the element clockwise at the top. At the bottom is anti-clockwise. So this is minus 5, minus 10, minus 15. Okay, so this is 5, 10, and 50. Okay, so let me see. I need more than that. Okay, so I need this to be at 20 or 25. So this is 15, this is 20, and then I need up to 25. Okay. So the scale must be the same, right? You can see over here, 2 squares, the delta is 5 megapascal. Okay. So this shear element rotate clockwise, element rotate anti-clockwise. So when you see from here, right, we are going to plot, we know that stress X and stress Y is equal to 0. So we know that this is our stress X and stress Y line. And then stress Z is minus 14.996. So I'm going to call it minus 15. Okay. So I'm going to draw a straight line on negative 15. So this line I'm drawing is the normal stress line for stress Z. Okay, it's 14.996, but I'm going to draw it as 15. Then our shear is 19.232. So no doubt I wrote down here as positive, but in shear it's not depend on positive or negative, but rather it depends on the rotation of the element. Okay. So no doubt down here is positive 19. You have to put them in positive 19 and negative 19. Okay. So I'm going to draw a line. Okay. So 19, as I say, I'm not liking the scale, but I'm going to put there as my 19.232. So likewise, this is my 19.232. Okay. So from here, I think I might need to draw this up to minus 25. So from here, we are now going to calculate, or we are going to determine. So usually what we do is we will label this as on this surface is our point X on most circle, right? This surface will be point Z, and this surface will be our point Y. Okay. So the easiest one is to look at point X. Point X has, let's not do point X. I'm sorry. Let's do point Y and point Z first. Okay. So if we look at point Y, it has 0 normal stress, right? So it's going to lie on this vertical line over here that I'm going to highlight. Okay. Right. But if you look at how the shear is flowing, I'm going to focus on the shear now, right? And if you were to put your finger at the center of the element, like the orange dot I've drawn, the element will rotate in this direction. And that direction looks to be anti-clockwise, right? So when that's the case, where it's anti-clockwise, right, we know that it has the normal stress is equal to 0. And then we can directly put this down, right? It's down here. And this is our point Y. Y is down here below the 0 normal stress rather than above. It's because of this arrow over here, right? It's rotating, generating, or the shear is generating an anti-clockwise rotation of the element. That's why it's down there. And then if you look at now, focus on point X and focus on this shear over here, right? And if you put your finger at the center at my green dot again, it will generate a rotation that is clockwise. So the normal stress, which is equal to minus 14.44 or 14.996, which is on the normal stress line, and it will generate an element rotation in a clockwise direction. So this is point Z. Okay. So that's why Y is below Z is on top. So from here, we can construct a line. So while constructing the line, I can, or we can now, where it intersects the x-axis, the normal stress line, we can draw a vertical line over here. And this vertical line, when it crosses zero shearing stress, this point over here, we usually call it our point naught. From here, right, we can determine a value which is known as our, I'm going to, yeah, we can determine a value over here, or the distance from 0 to point naught, or to point 0 to or point O to 0, okay, or the center of the, this is known as our stress average. And the stress average is very straightforward to calculate. So we know that the stress average is equal to stress X or stress Z plus by stress Y divided by 2. Okay. So this in terms will be equal to minus 14.996 times 10 to the power 6 plus by 0 divided by 2. So this is equal to, so 14.996 divided by 2 is minus 7.498 times 10 to the power 6 Pascal. Okay. So the next thing that we can determine, okay, so the stress average also, I should have written this down earlier, do apologize. It's also known as the center of circle. Okay, that is the center of circle. So the next thing that we can calculate is also the radius of the circle. Okay, radius of circle. So the radius of the circle is also known as our tau max. Okay, you don't see that yet. I will show you shortly. So if I were to write down where is the radius of the circle, so I just hold on, give me a moment. So just copy this line. I will paste, and I'm going to rotate this by 90 degrees. Okay. Ignore me for now, okay? This I'm just doing. Okay, so this over here, right? And this slope, or this, this is the radius of the circle, R, right? So to get the radius of the circle, right, we know stress average, and we also have this value over here, right? We have this value over here, the shear value, right? We have this value over here, right? So that value over there is our shear, that is 19 point what? 232. and set about 6. So our maximum